Good morning. Today we are doing 1-7 probability distribution with discrete random variables. A discrete random variable is a variable whose value is the numerical outcome of a random event. A probability distribution is a function that maps the sample space to the probabilities of the outcomes. In the sample space, they can be visually represented by a histogram, expected values gives us the mean or long-term average number of successes we can expect over time if we repeat the process over and over. So to find this, we find the sum of all possible values, each multiplied by their probability of occurrence. So knowing that, let's take a look at example 1. Number 1 says the table shows the distribution of the number of heads when 4 coins are tossed. First thing I look at is what is my total probability, because I need to make sure my total probability is 1. So to do that, I'm going to add them up. To add them up, I need common denominators. My common denominator will be 16. So 1/4 is really 4 out of 16. 3/8 is really 6 out of 16, and 1/4 is, again, 4 out of 16. So when I add those all up, I get 16 out of 16, which is 1, which is what our probability should be. And we need those common denominators because when we create a frequency distribution, we need to have the common denominators. So on the bottom is going to be the number of heads that I got, and over on the side is the frequency. So I can either have 0 heads, 1 head, 2 heads, 3 heads, or 4 heads, and I'm going to count up by ones. So 0 heads will happen 1 out of 16 times. So that's just going to get a 1. 1 head will happen 1/4 of the time, or 4 out of 16 times. So I'm going to put that up at 4 because when I am graphing frequency, I'm doing it all with the same denominator. 2 will go up to 6. 3 heads will be 4. And 4 heads will be 1. So what is the probability of getting 3 heads? So I go to 3. 3 heads is simply 4 out of 16, which is 1/4, which is 25%. Because when we talk probability, we are talking percentages. What is the probability of getting at least 2 heads? So at least 2 means I can get 2, 3, or 4. So I'm going to add all of those up. So that's 6 out of 16 plus 4 out of 16 plus 1 out of 16, which is 11/16. And that is 68.8%. And what is the probability of getting no more than 1 head? So no more than 1 means 1 or less. So that's here and here. So that is 1/16 plus 4/16, which is 5/16, which is 31.3%. Let's take a look at example 2. So example 2 says the instructor of a large class gives 15% of A's and D's, 30% of B's and C's, and 10% of F's. Let X be the random variable assigned to the student's grade on a 4-point scale, where A is 4, B is 3, and so on. So I'm going to create a probability table. So 4 was an A, and that is 15%, so that is 0.15. 3, and I'm just putting the letter there so we can associate it with a B, is 30%. 2 would be C's, and that is again 30%. 1 would be a D, and that was 15%. And then we have 0, which are F, and that is 10%. So if a student is selected at random from this class, what grade would we expect them to have? So anytime I see expect, what I'm going to do is I am going to multiply all of these things together and add them. So anytime you see expected, that's what we need to do. Four times 0.15 plus 3 times 0.30 plus 2 times 0.30 plus 1 times 0.15 plus 0 times 0.10. And I add that all up and I get 2.25. So a 2 is a C. So 2.25 is like a low C average. So anytime we see expect, you take the value times the probability and add them all up. What percent of the class is passing? So passing is everything above F. So we add those up. So that's 0.15 plus 0.30 plus 0.30 plus 0.15, and we get 90%. D, what percent of the class has a B or better? So B or better would be the A's and the B's. So that is 45%. Finally, let's take a look at C, or number 3. Number 3 says the table shows the probability for the number of people who live in a typical U.S. household. You'll notice one of these is blank. So we need to figure out what goes in there. Well, we know this should all add up to 1. So for A, it says, what is the probability of people living in a household with 3 occupants? So that's the one that's blank. So I need to subtract from 1 all the other numbers from it, because I know that row needs to add up to 1. Which I get 1.17, so that is 17%. And again, I'm going to go ahead and put that right in my table up here, so I don't have a blank, because I'm going to need that information for future problems. If a random U.S. household is selected, how many occupants would we expect to find? So that expect, remember, that means I need to multiply. That is the key word. So for expect, we multiply. So it's going to be 1 times 0.25 plus 2 times 0.32 plus 3 times 0.17, 4 times 0.15, 5 times 0.07, 6 times 0.03, and 7 times 0.01. We get 2.6 occupants. So the average household has between 2 and 3 occupants living in it when they took this survey. What percent of households have at least 11 or at least 5 people living there? So that would be 5, 6, and 7. So I add those up. It's 0.07 plus 0.03 plus 0.01, which is 11%. And the last one, what percent of U.S. households have no more than 3? So no more than 3 means 1, 2, and 3. So that is 0.25 plus 0.32 plus 0.17, and I get 74%. So that is it for this lesson and this unit. We are going to start on review after this and get ready for the test.